All right, let's look at how to find the string of 13 consecutive numbers in this giant 1,000 digit number that will give us the largest product. So what is this going to look like here? We're going to take a red box, and I'm just going to put a red box around 13 digits and calculate its product on the right-hand side. And what we need to do is consider any consecutive 13 digits. And so this red box is just going to keep crawling along, and you can see the multiplication on the right-hand side. We're going to have to check, in the naive approach, we're going to have to check almost 1,000 of these boxes and then remember the value of the biggest one. We could code that up rather in like a naive approach, and the processing time on that, the compute time on that would not be very long. But we're going to use some math today to make this more efficient. So as this animation runs, be thinking about how could we skip some calculations, make some calculations less burdensome. And if you're interested, the link to the code that I used is in the chat, but we're going to walk through the math and why that code actually works here. So the first thing I notice is there's a lot of zeros. And if we can handle these zeros in a smart way, we don't need to look at all these red boxes around the zeros. And if there's two zeros relatively close to each other, say less than 13 away, then we don't need to look at anything in between those zeros that are close to each other. And so we can just get rid of all of those numbers that are surrounded by zeros, and we can get rid of those extra zeros here and line everybody up again. So now we have less numbers to work with. So this is automatically going to give us less calculations here. And we can, for these new red boxes, we can just consider these. And we'll have far less than 1,000 calculations. The other thing you'll notice here is every time a red box approaches a zero, the zero is the 13th digit, we don't need to calculate 12 more times. We don't need the zero in the box. And so that's why the box is jumping to after that zero, because we're looking for the maximum value possible by multiplying 13 digits together. And so this is going to severely limit our calculation requirement. And next I want to reduce our processing or compute time even more. And instead of reducing the amount of calculations, let's actually make these calculations easier to do. And so when we look at each one of these comparisons that our code's going to have to do, we're doing this product of 13 digits in red, product of another 13 digits in blue, and I want to get rid of the product. And the idea here is if red's bigger than blue, then the log of red is also going to be bigger than the log of blue, because log is an increasing function. How is that going to help us get rid of the products? Well, we have to remember our logarithm rules. In the box here, we have what it means for log of a to equal x, and applying that definition, we can take ab equals 10 to the x times 10 to the y, take the log of both sides, and through some manipulation here, we get that the log of AB equals the log of A plus the log of B. And how we're going to apply this is, instead of saying the log of, in our case, A times B times C times D times everything, I'm going to break up the log of that 13 digits into the sum of logs. And instead of looking at this grid of original digits, I'm going to convert the grid into the log of those digits. And so when we compare red to blue, I'm no longer going to multiply all of red together and then multiply all of blue together. I'm going to add all of red together, which is a simpler calculation, and I'm going to add all of blue together. And what that's going to allow me to do is more quickly, even though it's the same amount of calculations once this box starts moving, it's more quickly able to just do the summations here. So what did we lose? Well, you have to do the log of every single digit, but there's only 10 digits available. And so we're really just mapping the digits 0 to 9 to their log values. And then from there, running through the summations. And so this red box is our leading candidate. And what the blue box is doing is it's going to the next group of 13 digits, one at a time, and we're just comparing the sums of these values as opposed to the product of these values. We still have the same behavior with here now when we hit negative infinity. We're just skipping ahead. That's our log of 0. And so we still have this skipping nature. We're still working with the reduced number of total values in our grid because we already got rid of the nearby zeros. So we're applying both our kind of first simplification of getting rid of nearby zeros and now our second location by doing the logs. And as you can see here, this can run very quickly because we're just looking, is anybody bigger than 10.371 when I add all of you together? And if we find out that nobody's bigger, then that's going to be the red box, which contains the largest product. Now, what are we going to do with this red box? Well, we need to undo what we did. 10.371 is not the answer. The number is going to be very large. And so what we need to do here is we're going to take these digits, reverse the log that we did to them, multiply them together, and that's going to give us the answer. I appreciate you watching. I hope you enjoyed. Don't forget to like and subscribe, and I'll see you for the next video.